All right, ready? 3, 2, 1, go. All right, guys, y'all ready? Y'all okay? All right, so we're going to go over that on Monday, and here's what I'm going to do. I'm going to hand back your notes so you get the whole packet and pass the whole packet either back or forward. The whole thing either back or forward. Will you pass it over to me? Yeah. Sweet time. All right, guys. So, unfortunately, I was not able to get all of the tests finished grading. I'm about halfway finished. They're pretty good so far, though. I am really hoping for Monday. Okay, I'm so sorry. I tried to get them back to y'all the next day, but I'm gonna shoot for Monday to get them back to you. Okay. So let's look at our learning targets for today. We have 3 of them. So I kind of had to move it on the white paper on the front of the room. I had to move it over to the side because my other classes are different than y'all now. So what's the first learning target that we're going to talk about? By graphing, right? So guys, when we graph something, what do we want to happen when we graph something? What letter needs to be by itself? The Y needs to be by itself, right? So if you flip to the back over on the next page, the very first thing that we're going to do is graph. So we're going to have 3 different types. So you might want to make yourself a note about when to use each type. So if you've got graphing on the next page, then make yourself a note about graphing. You want to have Y by itself, right? Make yourself a note about graphing. You want to have Y by itself. Because it's fine right now, but when we get to the other ones, you're going to be confused. Anywhere on the paper, yes, ma'am. Preferably not on top. Because we're going to be making some graphs on top. All right, so what we're going to do is we're going to take that paragraph, and since y'all are visual learners, we're going to write it in here for anybody that's not visual, but we're going to make ourselves some pictures up here on the top, okay? So let's look at the first one. What's the title of these notes? Alright, so if it says a blank is two or more equations with the same variable. System of equations. There you go. Alright, so you have a system of equations can be classified by the number of solutions. So you have a system is called consistent if it has at least one solution. So guys, this is what a one solution looks like. And if you're a visual learner, you might want to write that picture at the top to help you out a little bit. So guys, why would you think that would be called a one solution?
Because it only has one place.
There you go. Very good. It only has one place where they cross. That's why it's called a one solution. And we said that we were going to call that consistent. All right, and it's called inconsistent if it has no solutions. So leave yourself a little space because we have 3 of these. But over here on the side, we're going to write. So let me ask you this. If it has no solutions, what would the picture look like? Parallel lines. Very good job. So they'd be parallel lines, and this one is called inconsistent. So do you remember when we did functions, and we called it a function, and then we had to call it one-to-one or onto? Remember when we did that? So it's the same thing with these guys. If we call it consistent, we've either got to call it independent or dependent. And if we keep reading, it says if it has exactly one solution, like this first graph that we did, then we call it independent. So let's go to our little picture, and if it has one solution, we're going to call it consistent and independent. Alright, but the graph that we left blank for the middle is what we have right here. If it has an infinite number of solutions, what in the world do you think that means? It's what? Parallel is inconsistent. It's the same line. Very good. So if it's the same line, then it's also consistent because it consistently has every single point that's the same. Every single one is the same. Then we would call that dependent. So we would call that consistent and dependent. Y'all okay? Got all 3 graphs on there ready to go? Alright, so very first thing it says to do is to do what? Solve them, which means you have to solve for what letter? We got to solve them for y. So on your test, I could give you one equation, and I could tell you to solve it by graphing. I could tell you to solve it by substitution, which is our second learning target. Or I could tell you to solve it by elimination, which is our third learning target, and you will get the exact same answer all 3 times. So you have to be careful about which way it tells you to do it, okay? So we want to graph, which means, bless you, which means we have to solve each of them for y. Y'all know how OCD I am, so I'm going to have my 2 different colors. So if you learn better like that, then you do the same thing. If you don't learn like that, then don't worry about it. You do you. Whatever makes you learn better. So I'm going to solve this for y by subtracting x. So that would be 2y is equal to negative x plus 6. And then how do we get rid of that 2? You divide. Yeah, but if you divide it, you got to divide everything. Negative 1/2 x plus 3. And then I'm going to graph it. So I'm going to go up 3 to my y-axis, and then down 1 and right 2. And it's not a piecewise, so I don't have to worry about which piece. I'm just going to do the whole entire graph. And on these, you want to make it as large as you possibly can to make sure that you see where they cross, if they cross. And it's not an inequality like we did on our last test, so we don't have to worry about open lines or closed lines. If it's an equal to, they're always closed lines. And since we don't have a greater than or less than, we don't have to worry about where it's shaded. Are y'all okay? Yeah? Come on, it's Friday. We should be pumped up. We got a game today. We're almost done. We got the weekend. You ready? And y'all are like dead. Okay. All right. So I'm going to grab my different color to do the next one. And since I'm graphing, I need to solve it for y. So I'm going to subtract the 2x. So we get negative 2x plus 9. Huh? Yeah, we have to draw it in because it only has 8. Yeah, so we'll have to go up there. Then we're going to go down 2 and right 1. And when we do that enough, what do you notice happens? They cross. So look back at your little cheat sheet that we made with all the 3 graphs on it. If they cross at one point, what will we call it?
It would be constant and independent.
Consistent and independent. Very good.
Consistent.
But the thing is, on the ACT, they don't always ask you about consistent and independent. They want to ask you about the solution. So what's the solution where they cross? How much? It's 4 and... Is it 5? 1, 2, 3. Oh, it's 4, yeah. 4 and what? 1. So that is normally how the ACT will ask you the question. That way it gives you the opportunity to either graph it, to do substitution, or to do elimination, whichever one you like doing. All right, let's go to the next one. So I've got to solve this guy for y, which means I'm going to add the x over. And so then I can graph it. I'm going to go up 5 on the y-axis. And my slope is 1. So I'm going to go up 1 and right 1. I don't have to worry about dotted lines or shading or anything like that, which is cool beans, right? All right, on the second one, stay off your phone so you can stay with us because we're going kind of fast. So we're going to add that 2x. So we're going to get 2y equals 2x plus 8. Then we're going to divide by 2. And so we get y equals x plus 4. So we're going to go up to 4 on our y-axis, and then we got a slope of 1. It's not a piecewise, so we're going to go all the way across. And they are indeed parallel, Jared. Very good. So what we call that? Inconsistent. Very good. And just like when we did functions, if it was not a function, you were done. If it's not consistent, you're done. You don't name anything else. All right, let's flip over on the next page. Or for you, it's just on the next page. Flip over. All right, let's see what you can do with 3 and 4. Go ahead and try 3 and 4 on your own real quick. Alright, did y'all get that for number 3? Yeah? No? Oh gosh, I went to positive 2, didn't I?
Yeah.
I just realized that. I was wondering why y'all were just looking at it crazy. 1, 2, 3, 4, 5, 6. 1, 2, 3, 1, 2. Dang. I counted that wrong. Yeah, 1, 2, 3, 1, 2. I counted that one wrong. Man alive.
I did the same thing.
I just did that one is a little off. Jeez Louise. I'm sorry, guys. I screwed that all up, didn't I? There we go. Okay. Did y'all get that? Golly, that's a crazy hot mess right there. Alright, so if they cross at one point, what do we call that? An independent. Very good. And the ACT is going to want that point where they cross. So let's get in the habit and do that with us. So what's the point where they cross? How much? What's the x value? What's the x value? 4. Are you going to the right? It's positive 4. And what's the y value? 0. Alright, what about 4? Y'all finish that one or y'all need an extra minute? Alright, y'all take an extra minute on that one. Yes. Yes, yes, yes.
Miss Blackman,
Yes, ma'am?
did Isabella Ratliff make it in?
No, ma'am, she did not.
Thank you. Miss Blackman?
Yes, ma'am?
Isabella's on her way. She's going to have a pass from Officer Hand, and I'm going to fix her attendant.
Okay.
Thank you.
Y'all get that for number 4? They come out to be the same line? What do you call that when we come out to be the same line? And what? And dependent. Very good. Y'all okay? Alright, let's go to the next one. The next stuff doesn't say to graph anymore. What's it say to do now? Alright, that was our second learning target for the day, was to solve using substitution. Alright, so you might want to make yourself a little note on this one. So when we graph, we want y to be by itself, right? So when we do substitution, we just want a letter in general by itself. So you want a letter by itself for substitution. It doesn't matter what letter, but you have to have a letter by itself for substitution. Have to have a letter by itself. for substitution. When we get finished, yes. All right, so do you have a letter by itself? Yeah, what letter? So we can take what x equals and we can substitute it for x. So right here where it says x, we're not going to put x anymore. What are we going to put instead of x? Very good. Is this bringing back some memories from 9th grade? I hope so. Because next week we're going to take it and build on it. So what's the whole point of doing that? What's the only letter that you have now?
Y.
Y. So now you can solve for y. So we can distribute the 3. Then we have negative 15 minus 2. They're on the same side. So we're not going to do the opposite. We're going to add them together. Gives you negative 17. Y'all okay with that? All right, and then subtract the 9 over. So what would that give you? Beautiful. Then we're going to divide, and what do we get? 1. But that's not our answer. Because look at number 3 that we did earlier. That y value that we just found is only part of our answer. Because right here, our y value here was 0. What else are we missing? The x value. So now you got to plug it in. Guys, it doesn't matter where you plug it in. You can plug it in wherever. But what's the easiest one to plug into? The first one. There you go. If you do the bottom one, you'll get the same answer, though. You just have to do a couple extra steps. But this top one, most of you could go ahead and give me the answer. Is how much? Negative 2. So my answer that I circle, my answer that is going to get me credit on the test, will be an ordered pair. Which is? 2 and 1. Very good. So like I said, I could give you one question as a quiz grade. And I could tell you to graph it, which means you need to get everything y by itself. I could tell you to use substitution, and I could tell you to use elimination. So what happens if we were to graph this problem? What would happen at that point right there that we just got? It'd cross. So if it were to ask me to describe if it's consistent or inconsistent or dependent or independent, what would we call this one if they cross? Perfect. All right, let's look at number 2. Number 2, in order to use substitution, you have to have a letter by itself. Do we have a letter by itself? No. But I can make it have a letter by itself. Which one would be the easiest one? The top one or the bottom one? Bottom one. Pick one. It doesn't matter what letter we use. Which one? Y? Okay, let's do Y then. So let's see, that would become Y equals negative X minus 12. So we can take all of that and we can substitute it for y. All right, here we go. We had 2x minus 3, but I'm not going to put y anymore. I'm going to put negative x minus 12, and that's equal to 6. Then we're going to distribute that negative 3. We're going to combine like terms. We're going to move that 36 to the other side by subtracting. Divide by 5, and what's our x value? Negative 6. Perfect. All right, now I have 3 options. I can plug it into the top one. I can plug it into the bottom one. Or I can plug it into the one where I solve for y. Which one's going to be the easiest one? This one right here. Because this little negative sign with that x is going to cause you some grief. So let's plug it into the bottom one. Oh, I don't know why I circled that. Oops. So what's my x value? And what's my y value? There you go. That's your answer. So if you were to graph those, what would happen at -6, -6? Points they would cross right there, correct? So what would we call this one?
Consistent and independent.
Independent, right? Is everybody okay? Anybody lost? All right, let's flip over to the next page. Let's keep doing some substitution. You okay? All right, here we go. We got 2 more to do, and then we got to move on to elimination. I mean, like you can't stay for the rest of these. Let's wait till we get done, okay? Because I don't want you to be lost. All right. What letter? You gotta have a letter by itself, right?
Could you have a negative with the letter?
No. No. Cannot. So, what letter do you want to get by itself? Because any one you mess with is going to have just as many steps.
X.
X? Okay, which one do you want to mess with?
Bottom one.
You mess with the bottom one? Okay.
And wouldn't you like
The
ask
top
me?
one you just said.
Yeah, the top one doesn't have negatives, but you can deal with the bottom one. That's fine.
And like after you subtract the 3y, then you have to divide that into 1.
Uh-huh. Jared, you get the same answer, though, if you solve the top one for X. All right, so what are we going to plug in for X?
-3y plus 7.
Very good. And we're going to plug that into this guy right here. Now, Jared, did you solve the top one?
Solve it.
You just solved the bottom one? Okay. All right, so we should have 9y plus 3, but we're not going to put X. We're going to put -3y plus 6 is equal to 18. And then we're going to distribute the 3. Ooh, what about this guy? They cancel. And this is what I have left. You gotta think back to chapter, what, Madison? You gotta think back to chapter 1. All real numbers. Look at you go. So if I were to graph that, it'd be what, Madison? The same line. Very good. Because every single point, no matter where you put it, would be exactly the same.
So it would be, yeah.
If it wanted you to ask that, yes. But we're just doing that to make sure we're okay. It didn't ask us to do that.
Would there ever be a case where it's no solution?
We're going to do one like that. All right, number 4. Number 4, they don't give you X's and Y's. They give you A's and B's. How do you know which one goes where in the order pair?
A, and B, alphabetical.
Alphabetical order. Very good, guys. All right, y'all try number 4 real quick. See what you can do on number 4, okay? See what you can do on number 4. Alright, so did y'all solve it for A? You get that? You plug that in for A? Okay. Alright, y'all get negative 4, 6. Is your answer? Yeah? No? Still working on it? Good to go? Alright, let's look at the next one. The next one is our last learning target for the day, and it says elimination. So, let's make ourselves a note on elimination. So if we're graphing, what do we want when we're graphing? We have to have what by itself? Y by itself, right? Has to be Y, no other letter besides Y. When we're using substitution, though, any letter, but you have to have something by itself, some letter by itself. When you're using elimination, you have to have the same number with the same variable. So you might want to make yourself a note on that one. The same number with the same variable. Doesn't have to be both variables, just has to be one variable. The same number with the same variable. Alright? So what number is with M? And 1, right? 7 and 1, or 1 and 7, whatever way you want to say it. What numbers are with N? Negative 1 and 2, right? So do you have the same number with the same letter?
No.
Doesn't have to be both of them, but either the M's or the N's have to be the same. So now you can make them be the same. Which one do you want to make be the same? It doesn't matter.
N.
The N? Alright. So I need to make 1 become 2. What would I multiply? There you go. But the thing is, you got to multiply everything.
2 implies 2n equals negative 8.
Perfect. And then I'm just going to bring the bottom one over and line it up. Yes, ma'am. The sign's going to come into play with what we do next. Are y'all okay so far? Alright, so now they're the same number. The signs determine if we're going to add to get rid of them or subtract to get rid of them. So the word is eliminate, which means you need to make them go completely away, which means you need to make them become 0. So would you add negative 2 and 2 to make 0, or would you subtract negative 2? You would add them. But if you do it to one of them, you got to do it to all of them. So what's 2m plus 7m?
9n.
There you go. And negative 2n plus 2 is 0. But you don't have to write the 0 since you have the 9 there. And then what's 18 plus, oh, excuse me, that's supposed to be negative. Yep. Negative 18 plus 9.
9.
Negative 9. There you go. So a lot of your teachers may have taught you to multiply by a negative 2. I just don't like to do that because then that's one more thing that you could potentially get a sign wrong, like I did right here and messed up. So I just like to multiply by a 2, that way everything's the same. But it's not wrong if you multiply by a negative 2. If your teacher taught you that way and you like to do that, that's fine. Alright, so you get m equals negative 1, right? So you have 3 options to plug into. You have the original 2, and you have the one where you multiplied by 2. It doesn't matter. Which one? Excuse me.
Top one.
The top one? That's probably the one I would do. Oh, it's minus. So then we're going to add that 1 over. So we would have negative n is equal to negative 8. And then divide, and n equals positive 8. And what's your order pair? How'd you know the negative 1 came first? Alphabetical order. Very good. Very good. And so, guys, if we were to graph that, what's happening at this point right here? They're crossing right there. So if they wanted you to describe this, what would you describe it as? Very good. All right, let's look at the next one. Number 2. Number 2, you don't have anything that's even close to being the same. You have 2 and 3 with x, and you have 4 and 6 with y. Which one do y'all want to deal with? It doesn't matter. I deal with x's too because they're smaller numbers. So 2 and 3, what number does 2 and 3 both go into? So I need to multiply 2 times what number to be 6? 3. And I need to multiply 3 by what number? 2. Very good. So make sure you distribute to all of them. So you have two options. What happens if you subtract?
The x goes away.
The x would go away, Jared. Very good, because 6 minus 6 is 0. What happens if you added?
The y goes away.
Very good, because 12 plus negative 12 is 0. Which one do you want to do? It does not matter. You want to add? I like to add too. Subtracting is kind of, that's where we make mistakes. All right, so 6x plus 6x is 12x. Negative 12 plus positive 12 is 0. Well, we don't have to write the 0 because we got the 12 there. And 54 plus 6 is 60. Divide, and you get 5. And we have 4 options this time to plug into. We have the top 2, and we have the 2 where we multiply by. Which one? You want to do the top one?
Yeah.
All right. So we would say 2 times 5 plus 4y equals 18. Subtract the 10. Divide by the 4. 5 and 2. Very good. And just one more time, if you were to graph those, what's happening at that point? They cross. So what will we call it?
It would be consistent, and it would be
You just want to call it constant, don't you? You're just trying to call it constant. All right. Here we go, guys. We're going to do 2 more, and then the rest you'll have 3 for homework, okay? All right, here we go. We're going to do 3 and 4 together. So you could technically do this by substitution, right? What do you have to have with substitution?
A letter back home.
So you could actually solve that for y if you wanted to, right? But the directions specifically said to do elimination, right? Jonathan, are you good with this stuff, baby? Okay, go ahead and go to the bathroom then. Go ahead. And then you can catch up when you get back. But it specifically said to do elimination. So you have to get a number, both numbers to be the same. Do you want to do the x's or the y's? It doesn't matter, guys. Do the x's? Okay. So let's multiply that by 2 to make them both 4.
So it doesn't matter if one's negative or positive.
That determines if you're going to add or subtract. And they both come out to be the same again.
just add.
You have to add. And what happens?
Solution.
Very good. Alright, so the 4's cancel, the 2's cancel. So that's 0 is equal to negative 2, and that is indeed no solution. So if we were to graph that, what kind of picture does it look like? Parallel, very good, which we call inconsistent. Very good job. Very good job. You all okay? Alright, let's do one more together. And then those bottom 3 will be your homework, okay? So if you hustle, you can get most of that done before you even leave. Alright, what about this one? Which one do you want to deal with, X's or Y's? You want to do X's? Okay. So what about 4 and 3? What number do they both go into? 12. So you need to multiply 4 by 3 and 3 by 4. Here's where you need to be careful. The numbers that are the same are the 12s, right? How do you make those eliminate? You subtract. And you got to be really, really careful right here. It's negative 15, subtract 16. How much is that?
31.
Very good. Very good. and it's 51 subtract 20. You got to subtract everything. Positive 31. So divide and you get negative 1. Are y'all okay? Just gotta be real careful when you're subtracting. Which one do you want to plug into?
The bottom.
I'd probably do the bottom one because there's no negatives. Guys, you'll get the same answer no matter which one you plug into. So what's your order pair? How much? 3, negative 1. There you go. So if I were to graph that, what would it look like?
The 2 points of the box are going to become
Very good. Perfect. Perfect, perfect. All right, so homework tonight is 5, 6, and 7, and you have about 6 minutes left because we don't leave here until 3:02. So if you hustle, you could be the only class that doesn't have any homework this weekend. As soon as Jonathan gets back. There he is, right there.